The topic of this problem is electric power. The problem is to determine the missing quantity, the power in the second element. We're given that the power in the first element is equal to 36 watts. And it's absorbed power. So we have 36 watts absorbed into element 1. So if that's the case, then we know that using the well-known equation for power is equal to voltage times current, that the current in element 1 is going to be equal to the power divided by the voltage. And that's equal to 36 watts divided by 12 volts. And we also know that power is positive, so that means that our current is going to be positive flowing back in to the complex part of the circuit. So that if it were flowing through this circuit in this manner, it would be flowing through this direction, and the positive of the current would go into the positive polarity across element 1. So it's a positive current hitting the positive polarity of the element 1 voltage, which is 12 volts. And so the current in this case is going to be 3 amps. 3 amps of current flowing back into the complex circuit at the top of the circuit. The problem is to determine what the power across the second element is and whether it's absorbed power or if it's supplied power. We already know the current. We determined that from the information that we're given about element 1. That is, that it had 12 volts across it with a polarity shown and had 36 watts of absorbed power. We know that since it's absorbed, it's a positive power, and so that leads us to find the current is in the direction toward the complex circuit and is a positive 3 amps. If that's the case, that positive 3 amps is also flowing through element 2 from the bottom to the top. And so for element 2, P2 is going to be the current, 3 amps, and the voltage, which is minus 4 volts. The reason we chose minus 4 volts is because if you look at the current is flowing into the bottom side of element 2 where the polarity is negative. So the negative side of the 4 volt voltage drop across element 2 gives us the minus sign in front of the 4 volts. And so we end up in this case with 12 watts, so minus 12 watts of power. And that means that we have 12 watts of supplied power from element 2.